Question 1 of operation research is here. So the B part, the question goes thus. A repair shop attended by a single mechanic has an average of 4 customers per hour, which brings small appliances for repair. The mechanic inspects them for defects and quite often can fix them right away or otherwise renders a diagnosis. This it performs at an average of 1 in 10 minutes. Arrivals of customers. Arrivals are in Poisson distribution, while our service time has an exponential distribution. That is, it follows our assumptions for the model. Because part of the assumptions for the model is that our arrival rate must follow a Poisson distribution and our service rate has to follow an exponential distribution. So to interpret the question, it says a repair shop attended to by a single mechanic has an average of 4 customers per hour, which implies that our arrival rate, which is denoted as lambda, is equal to 4 per hour, while our service rate, it says this it performs at an average rate of 1 in 10 minutes. So our service rate is 1 per 10 minutes. But here we are working on hour, so we have to change these minutes to hour. And how do we convert this? Multiply, that means we have 1 all over 10 multiplied by 1 hour, and 1 hour equals to 60 minutes. So this gives us 6 units per hour. So the first question goes thus. Average number. We are required to find the average number of customers in the shop. That is the expected number of units in the system. That is number of customers being attended to and those that are on the waiting line. And this is denoted with this, which is equals to arrival rate all over service rate minus arrival rate. And we have our arrival rate to be equal to 4 all over service rate minus arrival rate, which is equal to over 2 equals to 2. That is 2 units, 2 customers, 2 vehicles. But here we are dealing with customers, so we have 2 customers in the system. The second question says we should find the average number of customers waiting to be served. That is the expected number of customers in the waiting line, which is noted as this and is equal to lambda square all over arrival rate minus lambda square all over service rate minus arrival rate, which is equal to square all over 6 into 6 minus 2. So we have 16 over 6 into 2, which gives us 16 gives us 16 all over 12. So ability to use our calculator effectively, we have 1.3333, and here we are dealing with number of customers on the waiting line. So it's not possible we have 1.333 customers, so we approximate to the nearest whole number, which means we have only one customer on the waiting line, which means a customer is being attended to, because we have altogether 2 customers in the system. So the third question, we are required to find the mean time the customer has to wait before leaving the shop. That is the expected time in the system. Expected time in the system, and is denoted as this. Is equal to 1 over 6 minus 4 equals to 1 over 2. We are working with an hour, so we can easily convert our hour to minutes, which will give us 30 minutes. This implies that a customer has to wait in the system for 30 minutes, or at the repair workshop the total number of duration to be used at the repair workshop is 30 minutes. The fourth question says we should find the mean time a customer waits before he is served. That is the expected time on the waiting line, denoted as WQ, equals to arrival rate all over service rate into service rate minus arrival rate, equals to 4 over 6 into 6 minus 4, which gives us 4 into 6 to 2, equals to 4 over 12. Using our calculator, we have 0.3333, and we are working on hour. So by the time you convert this into minutes, we have what? 0.3333 multiplied by 60 minutes, because we are trying to convert this hour into minutes, and that will give you what? 20 minutes. This means that each customer has to wait 20 minutes before being attended to. So the duration the engineer or the mechanic is using to attend to the customer is just 10 minutes, because each customer has to wait 30 minutes before leaving the workshop. Then the fifth one, you have to obtain the utilization factor of the mechanic repair. Utilization factor, or traffic intensity, which is noted as this, and it is equal to our arrival rate all over service rate, which is 4 over 6, and this gives us, using our calculator, we have 0.6666. So the sixth question there, it says we should obtain the probability that there will be 2 customers in the shop. Probability that we will be having 2 customers in the shop. So probability of having 2 customers equals to our traffic intensity raised to the power of 2 into 1 minus our traffic intensity. Here we have our traffic intensity to be equal to 0.6666 squared into 1 minus 0.6666 equals to 0.4443 into 0.3334. Multiplying this, we have 0.7038. That is the probability that we will be having 2 customers at the workshop. So the last question there goes thus: we should find the probability that there will be more than 3 customers in the workshop. This is for probability that we will be meeting 2 customers at the workshop. So the next one is probability that we will be finding more than 3 customers. Is probability of n greater than 3. And the formula goes thus: probability of n greater than k customers is equal to our traffic intensity raised to the power of k plus 1. So probability of having more than 3 customers implies our traffic intensity is 0.6666 raised to the power of k equals to 3 plus 1. So we have 0.6666 raised to the power of 4, which is equal to 0.1974. So thanks. Let us try with this and see how this goes, if we'll be able to work with this. Thank you.